Okay, today we're just going to look at parabolas just a little bit differently. Same formulas that we used the other day. So all those formulas will still apply. Same thing with the sideways parabolas, the x equals parabolas there. So same formulas. But now we're going to use so instead of giving you the formula, we're going to give you some information about this graph. So we know with all these graphs, the origin is the vertex of the parabola. There's a directrix line at x equals 4. So x equals 4 is a vertical line. So this would be a dotted vertical line at x equals 4. Because that's the vertex, we know that that distance is c between those two. C is actually negative in this case. But if we go 4 units in the other direction, we should find the focus point. So that focus point should be at negative 4 comma 0. You can see that c is 4, but it's got to be negative because it's opening in a negative direction here. Let's look at what the formula says for when you have this type of parabola. It's definitely opening to left or right here. So we know that x equals negative c, right? This is our formula. So if you just use the formula way of doing it, you could have said x equals negative c, so c must equal negative 4. It's probably obvious to you. And then a equals 1 over 4c. Well, if c is negative 4, then a is negative 1/16. So now we have our equation. X equals negative 1/16 y squared. And if you want to go one step further, since c is negative 4 here, the focal diameter is 2c in each direction, or 4c total. So I go 2c up and 2c down. And so the problem would look roughly like this. In fact, those are the 3 points I really want you to be able to graph on this. It's pretty wide because if you look at the formula, A is like really small there, so it's going to be really wide parabola. If A is big, it's going to be really skinny. Find an equation for the parabola that has a focus at 0, 8 and the vertex at 0, 0. I'm going to do this without the formulas first, and then I'll show you the formula way of doing it. So focus at 0, 8. So that's the focus at 0, 8, which means C must be positive because it's opening up, and C must be 8. If I go down 8, remember the vertex is always at the origin here. There's going to be a dotted horizontal line, which would be y equals negative 8. Now, if you're a formula person, you would have looked back at this, gone to the right formulas, which are these. The focus is 0 comma c. So 0 comma c. So c must equal 8. It does, right? We knew that. Vertex was 0, 0. You could also do the a equals 1 over 4c. So c is 8, so 4 times 8. So a is 1/32. So my equation is y equals 1/32 x squared. This is opening up, so it's a y equals parabola. And if I wanted to show off and graph this, it didn't really ask us, it said to find the equation, but let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So right about there, 16, that's 2c to the right, and 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I didn't do that very well, but 16 to the left, and then you have your beautiful parabola that goes through those points. Find the focus of the parabola that has a directrix x equals 8 and a vertex at 0, 0. So we've got a directrix line, x equals positive 8. The vertex here, which means the focus has to be here, 8 units in the other direction, which is negative 8 comma 0. Focus is always, in this c comma 0, so c must equal negative 8. It opens to the left, so that makes sense. Oh, that's all we had to find was the focus. Oh, it's kind of an easy problem there. Sorry about that. It's just too easy. Find the equation of the graph. So this one, it doesn't tell us a whole lot, except it says the vertex. You can definitely tell the vertex is at 0, 0. This looks like x equals 1. And that certainly is, again, the formula is c comma 0. So c is definitely negative here. C is negative 1. Right, you can probably tell it. So a equals 1 over 4c. So 4 times negative 1. So we get a equals negative 1/4. So my equation is an x equals parabola, because it's opening to left. So x equals negative 1/4 y squared. I think that was the question they asked. So got it. Graphing proposition is spider. So once you solve this for y, so you add 2x to both sides. Your y squared equals 2x. Solve for y, so one more step, square root of both sides, don't forget plus or minus. So y equals plus or minus square root of 2x. It doesn't really simplify there, but you would then get out your calculator. So the graph this as a function, we solved it for y. I take the positive case first, square root of 2x. And then on the graph the other side, which is put a negative in front, so negative square root of 2x. And you can see, like, if you graph it using functions, an x equals parabola is like, it's like made up of two kind of functions there. We know that that really is it's not a function, it's a relation. So that's why we can't, if we use functions, which these are functions, to graph it, it takes two functions to graph this particular relation. But that's what the graph should look like for that one, which kind of makes sense, right? It's opening to the right. If we had solved this for x, you would see that a little easier. So if you had like y squared equals 2x divided by 2 divided by 2, so x equals 1/2 y squared is the equation. So it's an x graph, it opens to the right. 1/2 is a little bit wider than normal, so it's a little bit wider parabola than normal if a was just 1 or something like that. And that's your lesson for today. I know that was quick, but there you go.